This is, what is this right here?
Rice.
What happens to you if you eat too much rice?
I don't know. You'll get fat.
Yeah, you can kind of get big and fat. If you eat too much food, you get big and fat. But they invented something called light rice. So we have just regular rice in here, and I'm just sticking this is just a chopstick, but this is just regular rice here. But they invented this other stuff. This is light rice. And watch what happens. I can just stick a chopstick in this rice, and it's so light, you can just lift it up.
That's good.
Isn't that awesome? It's like super, super light rice.
That's a little bit scary.
It's not really light at all. It's the same rice, but somebody explained to me, what's going on here? Why am I able to lift that up? What's the difference between these two containers? What do you think?
It got more in it.
Bingo, right there. Yeah, it looks like it's got the same amount in it, but this has a whole lot more in it. I just put a bunch of rice in there, and I crammed more in there, and I crammed more and more and more in there. So when I stick this in, oh, it's kind of hard to get it in there. Now there's so much in there that it kind of grabs onto that chopstick and won't come loose. This is even heavier than this is. But yeah, bingo. There's more rice in this container. Which container is bigger?
That one. That one.
This is a bigger container?
No, they're both the same size.
So density is the amount of stuff you can cram into the same size container. These are exactly the same size. I just crammed a whole lot more rice into this container. Right, unlike Madison's more scientific definition over there.
D equals stuff.
This is stuff. This is stuff. This air is stuff. This rice is definitely stuff. The amount of stuff I can cram into one equal size amount of space. The space isn't going to get any bigger. Like a balloon, if I blow in a balloon, I put more air into it, but the space gets bigger, right? So that's not necessarily more density. It's density is cramming more stuff into the same size space. That looks a little bit like gas. It's kind of like little molecules floating in the air. If I put more stuff into it, it gets a little bit thicker like that. Still kind of a gas. If I put even more stuff into it, it starts filling up the entire space. That's more like a liquid, like one good layer of more stuff. I cram more and more stuff into it. It gets so thick that it doesn't flow anymore. It's like a hard chunk. That's more like a solid. It doesn't flow. There's so much stuff crammed into that space. It's really, really, really thick. If I say this is a certain amount of space, this square right here, if I put some molecules in there, that might be a little bit like a gas, right? There's the density, if we did the math, is 1, 2, 3, 4, 5, 6, 7 things per 7 stuffs, 7 magnets per this amount of space, right? How many do you think we could put into there if we maxed out density? That'd be a little bit more like a liquid. We're just cramming more matter, more mass into space. More stuff! More stuff! More stuff! Okay, raise your hand if you think the beads are more dense than water and so they'll float. About 3 of you. Raise your hand if you think beads are heavier than water, so they are more dense than water, and so they will sink. Oh, so the rest of you are being chicken, huh? You're not going to say? We test it out? Check it out, check it out.
It's both.
Let me touch it, just check it out.
Those float.
Yeah, one sinks.
The white ones float. The white ones float and the blue ones sink.
What do you think? Yeah, partially, like you said, the blue coloring, whatever, the composition of these beads. And one of them, they're just more dense beads. So the plastic, the coloring, they're made to be more dense. So definitely the white beads are less dense than the blue ones. But the trick, part of how I tricked you guys a little bit, is what the liquid is. I asked you a question, would they float in water? But I didn't say this is water. What this is part of it is water, and then I added salt to it. So it's really salty water. I made it more dense, right, when I added salt to it.
Oh.
Right?
The water is picking up the lighter ones.
Just like in the egg trick, we made the water more dense when we added salt to it, right? And then I poured in alcohol, like the kind of alcohol you maybe clean your face with, or your doctor cleans your skin with, or you're going to get a shot. And so there's water, and salt, and alcohol. But salt wants to stay in the water. It doesn't go in alcohol. So when you mix those two liquids together, we have salt water, alcohol. But as soon as I stop mixing it, the alcohol and the salt water separates from each other. And so what you end up seeing is, when it comes back together, is alcohol, white beads, blue beads, salt. Right? Pick it up so everybody can see it. Up here at the top now, that's the alcohol that's starting to separate out from the water. It's the lightest, the less dense. I mean. So the alcohol, the less dense is up here. The next more dense thing are the white beads. And then this is still the alcohol and salt water mixed together. And then blue beads and salt. So what's the most dense? Salt water. And the second most dense?
Water. Blue beans.
Blue beans. And then, yeah, this mixture would be still a little bit less dense. And then
You should turn it upside down.
and then, so what do you think will happen if I turn it upside down?
The white ones are still gonna fall.
Yeah, but they turn over to that side and
Same kind of thing. What about this one? Do you think this one will sink or float?
float.
Float? What about this one? You think it'll sink or float?
Sing.
You think this one will sink? You think this one will float?
I don't know. Float.
Try it out. I think this was too big for here.
Yeah.
I'm surprised you got that right so universally. That this one is super solid. How about soap? What do you guys think about soap?
Oh, I did this before.
Blocks of wood.
What type of wood is it? I want to sing. Yeah, I knew it.
Yeah, rock. What do you think about a rock? Rock and a sinker
Sing.
float.
Oh, no, that's gonna float. That's not gonna sing. Yeah, they're floating.
Ready? I haven't let them go yet.
Red one gets float. Sing. Single float. Oh, it's floating. It's floating in the water.
What does regular Coke have that Diet Coke doesn't have?
Zero sugar.
This one has sugar in it. This one doesn't. That's the big difference. This one has a chemical sweetener that makes it taste sweet, but it's not sugar. The sweetener is really, really light. You know, read the label, find the word sugar, and find out how many grams is in a can of Coca-Cola.
39 grams.
Woo! Mercy! 39 grams. How much is that? So I have a question for you. If you went to a restaurant and they have packets of sugar on the table, right? You guys have seen this. And you get like an iced tea or something like that, and your parents let you put sugar in your iced tea. How many packs of sugar would your parents let you put into your drink?
I would guess one.
You bring your own day, you put one in.
Because if you put like 10 or 20, you would probably get sick.
If your parents just let you drink one, just 12 ounces, this is how many packets of sugar it would take.